Hello everyone, welcome to Harsh IT Lab. Harsh Verma this side. And today we are back again with our book Network Warrior, in which we are making notes. And today the topic for the day is FlexLink and Storm Control. So, for those who don't know, let me introduce you to the book. This is the book called Network Warrior. The book says that everything you need to know that was not on CCNA examination. And it's, I guess, it is not in the CCNP examination as well, but I'm not on the authorization slip that I can say anything about CCNP yet. But this book certainly does have some practical explanations that we will use in day-to-day lives, and it will aid in our troubleshooting steps. So you have already known that I'm not covering this book from cover to cover, but only making notes and points that I feel like it is necessary to understand and alleviate. So let's search into my phone, which is Poco F7, as you can see here, and start from the FlexLink topic for the day. The FlexLink are the layer 2 interfaces manually configured in primary or failover pairs. So up to now, you can understand it like a ether channel bundle in which multiple links are paired together for an uplink or failover. Okay, but they have different use cases than of STP, spanning tree protocol, whose primary job is to prevent loop. Because without any configuration, when we used to connect multiple links to two different switches, the STP triggered and gets one of or multiple ports blocked because it only wants to keep a single link as a keep life. Now, FlexLink ensures that a redundant pair in case of failure. So actually, when the main primary interface in case of STP gets blocked, it will take some recovery time. It may be 30 seconds, 20 seconds, 10 seconds, depending on the configuration, but it does take a few seconds of time. But FlexLink is kind of instantaneous and ensures a redundant pair. Now, FlexLink does not participate in STP and is only used when STP is not present on the switch. So, in case of older switches where STP was not prominent there, we used FlexLink in order to provide redundancy. Now, FlexLink does not require link to be of the same type or speed. For example, when we configure Ether channel, we usually use to pair. For example, if we are making Ether channel of two pairs of 1 gig link, so a total of 4 links. So we used to do that every type of port or every cable is of same kind. But FlexLink does not have these limitations. It can be paired with a single link and an ether channel or multiple different speed link, for example, a 100 gig link, a 40 gig link, etc. Now, only configuration required is on active link. And the configuration part is very simple. We just simply pass the command switch port backup interface and the interface that we want to use as a backup. Okay. And this is it about FlexLink. I guess that we don't use FlexLink nowadays because even in the data center environment or the networking journey that I have been covering through for the past 2 years, I have not seen a single FlexLink configuration. Maybe the place that still uses I have not been to. So for that is storm control. The storm control works by measuring the traffic in shorter increments, usually a 200 millisecond increment. If one exceeds the threshold, and the upcoming increments will be dropped until its configured rate are under defined rate. So basically, when we understand about storm control, we used to feel like that it will be configured as a policy shaping, that it will throttle the connection up to a speed limit. But this is now how it works. It actually divide or segregates the time into smaller time frame. For example, a single second will contain five increments of 200 millisecond each, and if one threshold exceeds, then the all forthcoming increment sectors will be dropped until the next threshold will be down. For example, it only works for the next increment. For example, we have five increments named as 1, 2, 3, 4, 5. One is fine, which is under, suppose we have set a speed for uh, in bits per second. Suppose we have set the speed for 100 bits per second. If the first increment is around 99, it will pass. Then the second increment, which is around 120, then it will, and it's consecutive. The third increment will also be dropped. Then the device will check whether the fourth increment is under 100 bits per second or not. If it is, then it will allow the subsequent to pass. So this under this circumstances, the storm controls works. Now, here are some commands to help to understand how storm control works. Okay, so we will go by it and understand. So the we are using a switch 3750, and the command is storm control, which we have options like action, broadcast, unicast, multicast. So we can segregate the things that on how much bits per second we want these kind of traffics. For example, we can set a separate speed for unicast traffic, separate for multicast, broadcast, and action. The action will be when we hit the certain threshold, what to do with that traffic. We can either shut down the port or send a trap notification to our SNMP server. SNMP server is basically a logging server. It may be a Zabbix server, Prometheus, or it may be Observium. Next is storm control broadcast level. Broadcast level is maybe in percentage from 0 to 100%, means the complete utilization of the link. For example, if it's a 1G link, then up to 1000 Mbps or 1024 Mbps, depending on your calculation, the broadcast level will be calculated. Or we can set a defined PBS, which is bytes per second, bits per second, and PPS, which is packet per second, and setting up the raising threshold. Basically, we can set two kinds of threshold. One is floor and second is ceiling. Okay. The floor defines from when we start the taking up the packets again. For example, the storm control broadcast level BPS, which is under 0%, or sorry, under 0 to once again, once tens, 100,000, 10,000, lakh, 10 lakh crore, 10 crore, means around 100 crore beats per second. Actually, I should have calculated in international numeral, which is once tens 100, 1,000, 10,000, 100,000, million, 10 million, 100 million, billion, 10 billion, around 10 billion bits per second. Okay. And then we have a value of KMG, which stands for kilobits, megabits, or gigabits. Then we can set the falling threshold, because we will start passing the traffic again when it's falls below this certain value, and we would also have the same parameters over here, and we can set it as kilo, mega, or gigabit. Now we can view our configuration using the show storm control, and for a specific thing, for example, broadcast traffic, unicast traffic, multicast traffic, and as per on the interface basis. Now, when multicast packets are suppressed, the routing protocol that use multicast will be affected. It's a very obvious thing. But the control traffic, such as the CDP traffic, will not be affected. So it is kind of a keep in mind when troubleshooting, because we see that no CDP traffic will be dropped, but every other multicast is being dropped. So it's create a kind of confusion that even if it's a case of loops or something, then every traffic need to be dropped. So when we know that this thing happens, this kind of behavior is shown by storm control, we can find out or point out the storm control more fastly, more advently. Next is the topic port security, and let me finish the port security in this video as well. So the port security is basically how we determine what happens when some kind of violation occurs on our port. For example, if another device, unauthorized device, gets plugged into our port, so what to do in that scenario? So basically we can do, or we can configure port security on the basis of the aging of the device, how much a device can connect, how long a device can connect, when basis of MAC address, that what we defined MAC address can be connect to that. We can increment using maximum, how many number of device can be connected to a single port. For example, a person may be using hub, so every now and then their MAC address change. So how many MAC addresses can be connected using a port, and we can set a violation counter or violation. So first we have to configure the port as access port using the command switch port mode access. Then we can configure switch port security, and then we can select the following things that I already mentioned. Now, to gather information about the connected device, we can use switchport port security MAC address sticky. And sticky means the address of the device that is connected to that port will automatically be learned by that switch. And protect is simply packet dropping, restrict the generation of SNMP trap in order to send as an alert to our Zabbix server or any monitoring server. Increment of violation counter while shutdown is transitioning to error disable mode. And yes, the error disable mode will automatically be port automatically be up after a certain period of time. We can also set that. It's look like that I have not mentioned how to configure the error disable timer. You can quick Google that. How can I automatically recover a port from error disable recovery state? Port security. In order to find it, you have to Google it. Next is switchport port security violation. We can select the violation in protect, restrict, or shutdown mode. And we have already explained that in protect mode, it simply packet drops. In restrict mode, it generates the alerts and send to the monitoring server, which we have to define as well. And finally, in shutdown mode, it will transition the port into error disable. Finally, the port security aging type. And we have absolute and inactivity. Basically, absolute means a port or device is certain to be connected for this specified period. For example, if we set it to the 30 minutes, 30 minutes, then after 30 minutes, the device will get cut off from the network. And finally, the inactivity, for example, a device is not being used or a port been disconnected for this long, the port will automatically be shut down or require some configuration changes in order to be used again. And finally, the switchport port security aging time. And we can configure this aging time in minutes, starting from the 1 to 1440 minutes. And that's it for this video. Thank you for joining. Thank you for watching.